Find the radius and interval of convergence of this power series sigma n from 1 through infinity, -1 to the n is square x n to n. Look at x to the n, which is same as x minus 0 quantity n. X minus 0, that means the center is 0. So in this case, the center we denote by a, that's 0. Okay, and we know the power series always converges for x equals center, x equals 0. For x equals 0, this power series converges, and it might converge for more x values, so we find that. Okay, so for x not equal to 0, not equal to center, we find the limit as n goes to infinity of an plus 1 over an, where an is this general term. Okay, this is an. So an plus 1 means just replace n throughout by n plus 1. Okay, so this limit is limit n goes to infinity of an plus 1. Just find an plus 1 from here. -1 n plus 1, n plus 1 quantity squared x n plus 1 over 2 raised to n plus 1. That's an plus 1 part, divided by, let me write in this way, divided by an. An is this, -1 to the n is squared xn over 2 to the n. Okay, this limit is equal to limit n goes to infinity. -1 to the n plus 1 is basically just plus 1 minus 1, plus 1 minus 1. Same thing here. So when we take absolute value, they become all plus 1, just 1. So this is gone, this is gone. So we have absolute value n plus 1 is squared times x raised to n plus 1, which is same as x raised to n times x raised to 1. I don't have to write 1. Same thing on the bottom. 2 raised to n plus 1 is same as 2 raised to n times 2 raised to 1. Now I want to change this division into multiplication. Then we need to flip this fraction. This is positive 1, so gone. 2n over n is squared x to the n. Okay, then we can cancel xn, 2 raised to n, 2 raised to n, and we have now x 2. So we can pull x into outside the limit, because this limit is just for n term, n goes to infinity, just for n plus 1 is squared and n is squared. So this is same as we can pull x all the way outside with absolute value of x over this 2. Absolute value of 2 is 2, and we have limit n goes to infinity of, what is left, n plus 1 is squared and n is squared. These are positive numbers, so we don't need absolute value anymore. So n plus 1 is squared over n is squared on the bottom. And let's find this limit. Okay, this is infinite limit because n goes to infinity. So this limit depends on the leading terms. So when we multiply n plus 1 by itself, square means we get n is squared plus 2n plus 1. Anyways, the leading term is n is squared, cancel, so 1. So this limit is in fact 1. So we have this limit of this ratio is x over 2. And we know from the ratio test the series converges if this limit is less than 1. Okay, by the ratio test, the series converges when this limit is less than 1, and the series diverges when this limit is bigger than 1. Okay, that is same as multiply both sides by 2, absolute x is less than 2. Okay, so the series converges when absolute x is less than 2, and the series diverges when x is bigger than 2. So this 2 is the radius of convergence. Okay, so the radius of convergence, let's say uppercase R, is 2. So we have this situation now. The given power series converges, I mean the center is 0, so this one, and now the radius is 2, so we can go all the way to 2 and all the way to left to 2, so that's -2. So the power series converges for all x in between -2 and 2, but since the ratio test fails when this limit is 1, so we need to test what happens when x equals -2 and when x equals to 2. They can be included in the interval of convergence. Let's see. So we need to test two endpoints. When x equals -2, the given power series becomes, okay, let me go down, the series becomes, let me write in this way, n from 1 through infinity, -2. Let's go up and see. When x is -2, so -2 to the n, -2 to the n, and -1 to the n. Okay, -1 to the n, -2 to the n. What's going to happen? -1 to the n, and when x is -2, -2 to the n, n, so we can write down just n. -2 times -1 is just 2, so that will be 2 to the n. Okay, so let's go, and then what else we have? N square over 2n. Okay, the series becomes -1 to the n square. We had x n, now we are replacing x by -2 to the n and over 2n. Okay, that's what we had, and we can combine these two. Let me see, do we have more? No, just that part. Okay, so this is same as now -1 to the n times -2 to the n, that's 2 to the n, and 2 to the n cancel. So when we multiply these two, we can cancel with this. Now we have n from 1 through infinity of n square. Okay, that's like 1 plus, this is 1 plus 4 plus 9 plus 16. Oh, it grows so fast. The sum is infinity. In fact, this series diverges. This one is, the sum is infinity. All that means the series diverges. Okay, n square diverges. So in our interval of convergence, we cannot include -2. Now we do the same thing for x equals 2. When x equals the right endpoint 2, the series becomes, so basically go up and see. So basically we are replacing xn by 2n, so we get n from 1 through infinity of -1 to the n squared. Now this is 2 raised to n over 2 raised to n. Okay, xn we are replacing by 2n. This cancel, -1 to the n squared. Okay, that is same as n from 1 through infinity, -1 to the n squared. This is an alternating series, but look at n squared. When n is very big, this is gonna be very big, either plus or minus. In any case, this is not gonna go to 0, so from the test of divergence, it diverges. So the interval of convergence does not include the endpoints. Okay, so finally the interval of convergence -2 to 2.